Here we go. Oh, got to put on my favorite student, good old Anne. Whoop, it's all of a sudden moved up, a little strange. Try that again. Name, good old Anne Serkey. Does great. Formula, NaCl. Okay. The name would be sodium. We say the metal first, don't change anything. And then we have the ide rule, chloride. And I will be fussy on spelling, sort of, in that I'm going to expect that it ends with an ide, not an een. Okay? I would probably go like this. 1 mark for that, 1 mark for that, because you'll find with this quiz being out of 30, 10 questions, each one is worth 3 marks. How many atoms in the molecule? Well, there's 1 Na, there's 1 Cl, 2. So 1 mark for the number 2 as well. That's how all of these are going to be marked, unless it's a formula. I'll show you how the formula part gets marked. Oh, calcium bromide. This is much tougher. Calcium, what I'm going to do is I'm going to write down off in the margin, or since I have room down there, calcium and its ion charge, which I think is 2+. I'm going to write down bromine. I know it becomes bromide in the name, and its ion charge. And then we had this thing that we called the crisscross rule. I think you're going to end up with CaBr2. Is that correct? I would give you 1 mark for having a Ca, and I would give you 1 mark for having a Br2. If you're missing the 2, sorry, you don't get the mark. How many atoms are there in the molecule? In this case, 3. 1 mark for that. So each one of these, you'll notice, is going to end up being worth 3 marks, I hope, when all said and done. It just got real. Because iron is multivalent, which means there's going to be some kind of a Roman numeral in my formula. What Roman numeral? I don't know. I have to figure it out. Well, I mean, I can tell you, hey, there's 3 atoms, 1 iron and 2 chlorines. Yay. How do I figure out which charge there is on iron? I do some scratch work in the margin. In particular, I look at chlorine, and I know that 1 chlorine has a charge of -1. How many chlorines are there in my formula? 2. How many negatives grand total are there in my formula then? Same answer. 2. So how many positives must I have? 2. How many irons do I have in my formula? How many irons do I have in my formula? 1, which must be worth those 2 positives. That's how, that's this, it's a complicated sequence, Ibrahim, but that's what my brain does. So this is going to end up being iron 2, brackets are optional, but Roman numeral 2, chloride. So I'm going to give you 1 mark for the iron, and you have to have the 2. And 1 mark for the chlor and the ide rule. There's a lot to that. I said the toughest thing is going from formula to name when they're multivalent. Going from name to formula isn't too bad because they told me which charge to use on copper. I'm going to go copper. I guess they want me to use a charge of +1. Sulfide. I always have to be careful with sulf and phosp because there's sulfide, sulfate, sulfite, and phosphide, phosphate, phosphite. So ide, that's the sulfur atom, which is, I got it here, 2-, yeah? Crisscross. Looks like I'm going to get Cu2S, is that correct? 1 mark for the Cu2, 1 mark for the S. Matt, how many atoms are there in this molecule? How many Cus are there? How many S's are there? For a total of?
3.
Nice. CaOH2. Calcium, is calcium multivalent? So no Roman numerals. Whew. In fact, I can almost go like this then. I can say, I know the first part is going to be calcium. OH. Oh, more than more than two capital letters. This is going to be a polyatomic ion. OH is, hello. Oh, hydroxide. Hydroxide. That's what that's called, calcium hydroxide. Matt, my friend, how many O's are there inside the brackets? How many H's are there inside the brackets? For a total of? And then what number is right here? For a total of? And then how many CAs? For a total of? Yep. It's tough to tell because 2 times 2 and 2 plus 2 are the same answer. Can you hold that question until I get to a more complicated one, and then you'll figure it out for sure? But 2 is a bad example because 2 times 2 and 2 plus 2 are both 4. Potassium permanganate. Okay. No. Potassium is that permanganate. I have no idea what the heck that is. That's got to be one from the back because I know that's not. Now, by the way, now you're starting to realize why I got you so familiar with the periodic table. It's not just that you need to. This way you can know permanganate's not on the table. There's no element called permanganate. Permanganate, MnO4 negative. MnO4 negative. Oh, this crisscrosses very nicely. 1 and 1. So the formula is going to be KMnO4. You could do this, but do I need to bother putting the 1? So you know what? The brackets in this case would be redundant and unnecessary. I wouldn't take marks off for it, Franz, but have you noticed if I don't have to write something, I won't write something. I'm efficient and lazy. Matt, you're on cue. You ready? How many in here? And I know I didn't walk you through it this time. How many Ks?
1.
How many MNs?
1.
Right? And how many Os?
1. Or 4.
For a total of? 6. Right? Don't just count letter. MN is one thing because the lowercase m tells me belongs to the M. What is MN? What is MN? It's manganese or it's manganese. I always get it because magnesium and manganese I get mixed up all the time. Hannah, now I can answer your question. You ready? How many CRs are there in the brackets, Hannah, my joy? How many O's? For a total of?
7, 8,
9. In the brackets, 9. And then there's 3 of those. 9 times 3. 27, you say? And then how many COs? For a total of? Yep. Just like that. This is already a pretty big molecule. CO is cobalt. Is cobalt multivalent? Oh! Roman numerals. Okay. So I'm going to go like this. Here's CO. What I'm really going to look at is the Cr2O7, this weird thing that's called dichromate. Now, one dichromate has a charge of 2 negative or minus 2. You okay with that, Hannah? How many dichromates are there in this molecule? So, if one of them is negative 2, how many negatives do I have grand total? Negative 6. So, how many positives do I have to have? Positive 6. How many cobalts, Brady, coming back to you because you were away? How many COs do I have? So what does each one have to be worth so I get a total of positive 6? 3. That, again, that's a pretty hefty set of mental gymnastics. Apparently, this is going to be cobalt 3 dichromate. Wow. Whew. 1 mark for cobalt 3, 1 mark for dichromate. It was dichromate, yeah? Yeah, because there's chromate and there's dichromate. Okay. And then 1 mark for the 29. No marks for the scratch rough work, but I have to use it. I really can't do these in my head. Maybe if you really force me to, yeah.
Couldn't you just, since it's past the crisscross rule in the formula, just take the 3 and put it over the CO, and take the 2 and put it over the
An uncriss-cross?
Yeah.
That works in this case, but it won't work if it's been a question that was reduced. So I have to walk through it. I've learned. I taught it that way the first time, and then I went, oh, wait a minute. Any question that ended up getting reduced, the kids are all getting wrong. In fact, so you'll find one later on here, I hope, where that won't work. If I've done my job right, we'll find out. Manganese 3. Oh, they gave me the name. Mn, it's going to be 3 plus. Phosphate, 8, that's on the back. Phosphate, PO4, 3 negative. Here's a good example, Evan. Great question. Because when I crisscross, I'll get 3 and 3. No, I won't. I'll reduce it. I'm going to get 1 Mn and a single PO4. But now if you tried uncrisscrossing, you'd be telling me it was manganese 1 phosphate, and I would beg to differ. 1 mark for the Mn, 1 mark for the PO4. If you put 3 and 3, I'll give you a half mark for each one, but I would say to you, no, it's crisscross and then reduce to lowest terms. Yeah.
Or if you put the 3, then you cross it out.
So you crossed it out, then I'll live with that. But why would you write stuff that you don't need to? I'm just saying. And it looks like this has 1, 2, 6. 6. MO, is MO multivalent? This is molybdenum, yeah? Is MO multivalent? Duck! Sorry. Okay, so what is the charge on MO? I don't know, but I also have CrO4, which is chromate, which is normally 2 negative, but there's 3 of them. That makes a total of 6 negatives. So this is also has to be 3 plus to get a total of 6 negatives because there's 2 molybdenums. Here that worked, Evan, because we got one that was not in lowest terms. I just wouldn't use that as a general rule because you'll get in trouble when it's in lowest terms. So this is going to be, oh good gosh, now I got to spell molybdenum, okay. Molybdenum, is that right, Mr. Duke? Really? Wow. 3 chromate. Yes? Now let's see if I can move this up just a tiny bit. No, okay. Whatever. It's going to go on to the next line. 1 mark for the molybdenum 3. Can't even trouble say that. And 1 mark for the chromate. Oh, this will be a fun one. Inside the brackets, there's 5 times 3, 15. 2 more, 17. Is that right? Yay. Ammonium phosphate. Ammonium. Huh? Oh, that's the rare polyatomic ion that's positive. In fact, this year, that'll be the only one that you run into that's positive. There are others, but this is the only one. Ammonium, I think, is NH4 plus. And phosphite, PO3, 3 negative, PO3, 3 negative. So if I crisscross, I'm going to get NH4 in brackets, 3 of them, PO3 in brackets, 1 of them, so I'm going to ditch the brackets. That's terribly messy, Mr. Duick. Let's make that a little neater. NH4, 3 of them. PO3, 1 of them. Is that okay, Franz? How many atoms are there? Oh. Inside this bracket, there's 5 times 3 is 15, 16, and 3 O's. Is it 19, I hope? Again, 1 mark for the NH4 in brackets 3, 1 mark for the PO3, 1 mark for the 19. Could you give yourself a lovely score at the top, please, out of, count 'em, 30? So, a little bit of science 10. As I said, this is like a preview of coming attractions. This is a trailer, this is a teaser. You may recall at the very beginning of this year, Brooke, I said to you, the periodic table is the alphabet of the universe. And then when we started doing the crisscross rule, I said to you what I was teaching you how to do was how to spell 2-letter words. Today I'm going to teach you how to write sentences. Okay. Small sentences. We're going to be, Maddie, right around the whole "the cat sat on the mat" stage. We're not going to be doing long, but we'll start here.
All right.
This may be the toughest and coolest topic that we do all year. If you find it difficult, it means you're normal. It's hugely important in Science 10 and Chem 11 and 12 if you take that. So, let's start out with our setup. If we combine two chemicals together, a new product may be formed. Not always. Some chemicals don't react with each other, but sometimes. This is called a chemical reaction. This is the fun stuff. Some terminology. This part is still fair game because I mentioned this last class. Substances that react are called, who can remember what we called substances that react? I'll give you a hint. The word, yeah, reactants, okay? I was going to say I'll give you a hint. The word react is in the name. What do we call the substances that are produced? Products. We have to start off with a law, a rule. Okay? This law is what's going to allow us to confidently predict the future or write sentences in chemistry, write chemical sentences. And the law says this: you can't create or destroy atoms. The number of atoms that you start with of each type before a chemical reaction has to equal the number of atoms that you finish with of each type. Atoms can't magically vanish or appear out of nowhere. So therefore, the same number of atoms must be present after the reaction. And this is called the law of conservation of mass. Mass is a science word for matter, for stuff. Conservation means it doesn't vanish or magically appear. The amount you start with is the amount you end with. Conservation laws, Ibrahim, are very important. In physics, for example, two of the big laws in physics are the law of conservation of energy. It says that energy can't be created nor destroyed. Whatever energy you start with, that's how much energy you end with. And there's the law of conservation of momentum. So conservation laws are important. Well, in chemistry, there's the law of conservation of mass. Atoms don't magically appear or vanish before or after. This is what allows us to predict chemical reactions ahead of time. So here is an example. Let me blow this up so you guys can see it nice and big. Here is an example of a chemical sentence. It's saying, if you start out with 2 molecules of H2 and you add to it 1 molecule of O2, so how many oxygen atoms are there on the left? How many hydrogen atoms are there on the left, grand total? 4. How many oxygen atoms have I better have on the right? 2. How many hydrogen atoms have I better have on the right? 4. Otherwise, it's an impossible sentence. You end up with, well, you know what? This is if you take hydrogen and oxygen and you light a match or you add flame, you get an explosion and water. I showed you a video earlier this year of blowing up a little balloon. Oh, how many oxygens are there? Well, it looks like there's 1, except what number is in front here? So 2 of 1, 2 oxygens. And it looks like there's only 2 hydrogens. Wait a minute, what number is in front here? 2 times 2. Hannah, yes, it's going to be timesing again. 4 hydrogens. This equation is balanced. Here's an example. Now, not every equation will have this, Brady. Some will. The lowercase g tells you this is a gas, and your product is a gas. What if instead this was a solid? What letter, lowercase letter, do you think they'd put there? S. What if this was a liquid? L. Okay? I'm not going to put that on every equation, but you'll see a few equations where I yoink them from a specific chemical reaction. Christian might have the subscripts. You don't need to worry about that. It's just kind of nice, oh, apparently I get a gas at the end. So this is saying NO. NO, that's not the word no because it's 2 capital letters. This is called nitrogen monoxide. How many molecules of nitrogen monoxide are we starting with? So 2 molecules of nitrogen monoxide reacted with 1 molecule of O2. Now, oxygen is kind of a weird one. Oxygen is so reactive that it's never by itself as a single O. You'll see it in a chemical equation always written as O2 because if it's by itself, it bonds with itself to form a pair. You'll never see me write just an O on its own. You'll see me always write an O2. In fact, there's a bunch of molecules of elements that are so reactive, Maddie, that they bond with themselves. They're called the diatomic elements. We'll talk about how that works. So 1 molecule of O2 to form, how many molecules of the new product do we have? How many molecules of the new product do we have? 2. 2 molecules of, now NO2 would be called nitrogen dioxide. By the way, nitrogen, metal or non-metal? Nitrogen, non-metal. Oxygen, metal or non-metal? This molecule, ionic or covalent? This is covalent. The naming for covalent is different. For covalent, we use prefixes like mono and di. That's why carbon dioxide. You've certainly heard the chemical. It's a covalent bond. The coefficients tell us, so the coefficients, the numbers in front, not the subscripts, the small numbers, but the coefficients, the numbers in front, tell us how many molecules are involved. The letter in the brackets indicates the state. So we can fill out 3 of these. What does G stand for? Gas. What does S stand for? What does L stand for? Here's a new one. Anybody know what AQ stands for? Good guess. Except then we'd use a P or something. So it stands for aqueous, and that really means dissolved in water. A lot of the time in a chemical reaction, we'll take a solid, but we want to mix it with the liquid, so we'll dissolve it in water first. Maddie, we won't always bother with the states. Sometimes you'll see them there, sometimes you won't. So, let's try this. We need to then balance the equations. Eventually, probably in Science 10, you'll reach the point where you do much of this in your head, but I'm going to go really slow on purpose. How do we do this? You determine the number of atoms for each element. So right now, what number is down here in front of the Mg?
1.
So right now, there's 1 Mg. How many oxygens are there right here? What number is down here next?
A 2.
Okay. On the right-hand side, how many Mgs are there? 1. On the right-hand side, how many oxygens are there? This is not balanced. And the reason it's not balanced is the O's don't match. The Mgs do. So how can you balance an equation? You're not allowed to change numbers down here because those came from the crisscross rule. Those are the laws that you were required to follow to combine those chemicals in the first place. What you can change are the coefficients. I'm allowed to write a number here or here or here. What's not balanced? The oxygens. Brooke, how many O's on the left? How many on the right? So I can go like this. All of us, we can put a 2 there. How many oxygens are there on the right now? 2. But what else changed on the right-hand side? How many mg's are there on the right now, Brady? Am I balanced yet? Nope. How can I fix that? Put a 2 there. What this is saying is if you want this chemical reaction to occur and have nothing left over, you need 2 magnesiums for every every O2 atom, and that will give you 2 molecules of MgO, of magnesium oxide. That's balancing equations. So if you look at the steps, it says determine the number of atoms in each element, pick an element that's not balanced, not equal on both sides of the equation, add coefficients in front, not subscripts, Mason. You're not allowed to write the small numbers, can't change those. Add coefficients in front, but every time you add a coefficient, ask what else changed? And if you do it right along the way, continuing to add coefficients, suddenly you'll go, duh! It's balanced. Little note, the coefficients have to be whole numbers. You can't have decimals like 0.5 of a molecule or 0.6 of a molecule. Let's try another one. Okay. We're going to combine calcium and O2. We're going to get calcium oxide. How many calciums are there on the left-hand side, Danielle?
1.
How many are there on the right-hand side? Yay, it's balanced. Or maybe not. How many O's are there on the left-hand side? 2. How many O's are there on the right-hand side? No! So it looks like I'm going to start with the O's. And the first thing that I would do is I would say, well, I can make 2 O's by doing that. That certainly changes the number of O's, but Danielle, what else did that change? How can I fix that? Are we balanced? Yep. I wish it was always that easy, but I'm giving you very carefully contrived, boring ones. Let's kick it up a notch.
Mr. J.
Yo.
Oh, why do you leave the box in the middle blank?
Oh, there's technically a 1 there, but am I going to bother writing a 1?
All right.
Okay. In fact, you're going to see I stopped putting boxes. I'll put blanks, but by the time you get there next year, they'll just leave a space, and it's optional whether you, because sometimes you won't need to put something in front of it. Sometimes you will. Okay. We're going to combine nitrogen. Nitrogen is one of those diatomic molecules in that it pairs with itself, which is why we have N2. And hydrogen, turns out hydrogen is also one of those diatomic molecules that pairs with itself. And we want to get NH3. NH4 is ammonium. NH3 would be nitrogen trihydride, but I think that has a special name. Okay. How many nitrogens on the left? How many nitrogens on the right? 1. How many hydrogens on the left?
2.
How many hydrogens on the right?
3.
Are we balanced?
No.
Nope. Now, some tricks of the trade. Always save hydrogen and oxygen for last, because you're going to learn next year hydrogen and oxygen combine in such unique ways. They'll often split up like crazy, and it's really tough if you start with them. But if you save them for last, often, Sierra, you'll find they balance themselves. Not always, but often. So I'm going to start with nitrogens. How many nitrogens on the left? 2. How many on the right?
1.
How can I fix that? Now that's going to give me 2 of those. Oh, what else is that going to change? It's going to change the number of H's. 5 or 6, Hannah? Hannah, how many H's do I have on the right-hand side now? How many H's do I have on the left-hand side? 2. How can I fix that? How many would I like to have on the left-hand side? 6. How many do I have right here? How can I turn this into a 6? Alex. There you go. N2 plus 3 H2s results in 2 NH3s. That'll balance and you won't have anything left over. Oh, and there's an invisible 1 in front of the N2. But let's kick it up a notch. Cu2O plus C. So copper, which copper? I don't know whether that's, I think that's copper 1 oxide plus carbon gives copper plus, oh, what's CO2 called? Yeah, carbon dioxide. Okay. Start out by listing. How many Cus? 2 and 1. How many Os? 1 and 2. How many Cs? 1 and 1. The Cus and the Os don't balance. Duick says save the Os and the H's for the last. Trust me. So I'm going to start with the Cus. 2 on the left. How many on the right? Okay. How can I fix that? Put a 2 there. Okay, now let's look at the O's. How many O's on the right? How many on the right? 2. How many on the left? How can I fix that? Uh-oh. What else? So that changes that. But what else just changed? How many Cus do I have now? How many coppers do I have? 4. I'm not balanced with my coppers anymore. How can I fix that? I think, what number should go there? You do a lot of crossing out and scratching out with this. Trust me. That's okay. We're okay with that. I guess if you start out with 2 Cu2Os and you add 1 carbon, you'll get 4 copper atoms by themselves and 1 molecule of carbon dioxide. Couple more. So some hints. If you see a polyatomic ion, treat it like one weird atom. Unless you notice that on the right-hand side, it's split up. But if you notice you have a PO4 on the left-hand side and a PO4 on the right-hand side, treat it like one weird funky thing. Say what? Oh, and hint number 2, save H and O for last. Now you'll notice, Drew, I'm giving you a lot less to work with here. Okay. So now we're going to do a full list. We'll do example 1, example 2, and then I'm going to press pause. Then next class, we'll work our way through the rest of these, and I'll give you some to practice. We'll also mark the take-home quiz. So example 1, I go like this. Well, there's one of those. How many H's are there on the left-hand side right now? 2. SO4. Is that a polyatomic ion? I think so. Did it reappear on the right-hand side? So rather than split it up into an S and into an O, Jaden, I'm going to say, you know what? How many SO4s are there? 1 of them, because there's no brackets or number in front. How many RUs on the right-hand side right now? Loud and proud. 1. How many H's on the right-hand side right now? 2. How many SO4s on the right-hand side right now? 3. By making this list, Nick, it becomes pretty obvious to see what's not balanced. I'm going to be targeting the SO4s. What are the SO4 sulfates? Whatever. SO4 is easier to say. I'm going to be targeting the SO4s. So how am I going to fix that? Well, How many SO4s do I have on the right? On the right? 3. How many on the left? So the first thing I'm going to try is I'm going to put a 3 there. Now that'll fix that. But what else just changed? How many H's do I now have? 2 times 3. So cross that out, 6. How can I fix that? Well, I got 6 H's on the left. How many H's do I need on the right? How many do I have right now? How can I make this into a 6? What am I going to put in front here? A 3, because we're timesing. That equation is now balanced. 1 atom of, is Ru rubidium? I think it is. Plus 3 H2SO4s leaves 1 RuSO4 3, and then 3 extra atoms of H2, 3 extra molecules of H2 kicking around. I could even be more specific. Sierra, because I know that hydrogen is a gas, I can tell you that if you mix these together, bubbles would show up if it was a liquid, because the hydrogen gas would bubble off. So now we're really starting to predict kind of what's going on with chemistry. Last one. NaOH plus H3PO4, Na3PO4, H2. Okay. See the PO4 here? See the PO4 here? I'm going to treat that like 1. Now, OH is also a polyatomic ion. This is hydroxide. Do you see an OH over here again? You know what? This one I might end up splitting up. So you ready? I'm going to go like this. Nah. Looks like there's 1. There's 1 O. Ooh. How many H's are there on the left-hand side? Careful. What, Alex? 4. 3 here, 1 here. Wow. 4 of them. And how many PO4s are there? 1. On the right-hand side, how many NAs are there? 3. How many O's are there? Now, I'm not counting this O because I'm treating this O as part of the PO4. I'm only looking at this separate O here. How many are there? 1. How many H's are there? 2. And how many PO4s are there? 1. So Trevor, step 1 is list what you got. By the way, a lot of my students, by the time they get good at this, they skip this step and they just go straight to tracking it all in their head. It can be done. The H's don't match. I'm going to save them for last. Oh, you know what? I'm going to start off with the NAs. I have 3 on the right, 1 on the left. Right? That's going to change that. Oh, that's going to change that. Yeah. And that's going to change. How many H's are there now? Let's see. 3 here. 3 here. 6. Okay. Is that okay? By the way, it's easier for me to do examples and explain all the rules. You guys are figuring out, oh, and now you're kind of figuring out how the numbers work and how the multiplying works, right? What doesn't balance now? The H's and the O's. Okay. Yeah. How many H's are right here? How many H's are right here? No. How many H's are right here? 1 times 3 is? 1 times 3 is? So there's 3 H's in this molecule, 3 H's in this molecule, for a total of 6. Good question. And I think it's the H's now that we need to balance. How many H's, Katie, do I have here? How many do I have here? So I'm going to go like this, and I'm going to say if I put a 3 there, that would give me 6 of those. What? How many O's do I now have on the right-hand side as well? This is why I said you save the O's for last, because if you're lucky, they'll balance themselves. Whew. So we're going to pause. Next class, I'll introduce Mr. Hofbrinkel. Yep.
Where's the,
Next class, you're going to get the rest of class to work on it.